Hello all. In this lecture we discuss about basic programming of 8085, general programming method. So first of all, this concept is necessary for the advanced programming method. The first program is complement 8-bit number and stored in the memory location. Consider in a 900 hex location there is a number stored XYH. This is a typical form. So first of all we load the number by the memory pointer and then accumulator, transfer it in the accumulator, and then we execute complement accumulator, and after this we store by STA 9001 hex location. So after halt the program is ending. So now this code is execute the complement of the 8-bit number in 8085. Now if we take the 2's complement of this number, now that programming 2, now we take 2's complement of this number. So what will do that? So the programming approach is same. Just to insert here INR A, and if INR A and then store, then we take the 2's complement of this number. Okay. Number 3 is very important. Say in a 900 hex location there is a number is stored XYX. Okay, check that this number is 0 or not. So how we will do that? So it is very easy. So LXI 9000 and then transfer to the accumulator and transfer to the accumulator. Okay, then the logical OR operation performed to the accumulator itself. So OR immediate or instead of or A. Okay. So now if the number is 00, then between these the same number accumulator content, if accumulator contains 00, then 00 or 00 equal to 0. Okay. So now carry flag is 0 flag is set. So jump if no 0, depending on this decision we can store the number. Okay. So jump if no 0 L1. So if the number is not equal to 0, then we store say we store 01. We store 01 in the memory address 9001 to signify that, or to indicate that the number is not equal to 0. But if the number is 0, then we directly store the number in 9001. Okay. And here also use the halt. The two halt are used because when it is jump, then this halt is executed, and when this is not jump, then this halt will be executed. Okay, so this is a programming method by which we can check the number is equal to 0 or not. In the later session, this programming is we will develop this programming in the 8085 simulator ID, either the number is 0 or not. Okay, so now the fourth programming method is the task to rotate the number using RRC instruction. So there are 4 instructions available: RRC, one is RAR and RLC and RAL. So this is rotate accumulator right not through carry. This is rotate accumulator right through carry. This is rotate accumulator left not through carry. This is rotate accumulator left through carry. So these 4 rotate instruction is very important to rotate any number in the bit pattern. In this bit pattern, accumulator bit pattern, there is a D7 to D0, and one thing should be remember: this rotate instruction only perform when the number is stored in the accumulator, neither B, neither C, or neither D, or any one register. When the number is stored in the accumulator, then this operation is performed. Okay, so rotate accumulator right, left, there are 2 every instruction have 2 pair. So now this is a special instruction. So now number 5 is number 4 is a rotation related instructions. Okay, so number 5 is that our task is to add 24-bit numbers. So what will do that? So 24-bit numbers means, say the number is PP, QQ, MM. This is first 24-bit numbers, and second 24-bit number, say for example XX, YY and ZZ. And after the summation of these two numbers, the summation is, let us consider this is A, this is BB, this is CEC, and this is carry output. That means after addition the result will be 32 bits if we provision this carry bit. Okay, 32 bit. So this first 24 bit, this is the second 24 bit, two numbers, and the summation either is 32 bit if carry is generated, or summation equal to 24 bit if there is no carry. So how will we store this number in the memory array? So it is very important. Okay, either the programming is not successfully written or result is there is an error generated in the result. So now first of all here we stored mm, and then here we stored qq, and then pp. So this is the first 24 bit numbers, and the later there is a 9003, there is a 9004, there is a 9005. Here we store first zz, then yy, then xx. So now these 3 byte remain without it with to create the 24 bit number, second 24 bit number. And here after the addition, here store our result a, b, b, cc and co. So this is a carry bit and this is a sum bit. Okay, so this is a method by which we can add the 24 bit numbers in the 8085 accumulator, 8085 processor. So how we will do this? First, these are consider 16 bit operation, and then if the carry is generated, if there is carry generated, so it is named as say carry generated, say cg. So after the carry generated, these remaining 3 bits addition with this and make the another sum and carry bit. Okay, so how will do that? So this is for this is we first store mvic equal to 00. This is initialization 00 for carry generation method. This is very important. Okay, so now next our task is to load the number appropriately by using LHLD instruction. So LHLD 9000 and exchange this value to the D pair. In the previous video we will discuss about 16 bit operation. So now what is the target? The target is 9003 because in a 9002 the MSB bit is stored. So now here we perform the DAD operation, DAD D operation. DAD D means HL pair plus D pair addition between these two register addition between them, and the result is stored in the HL pair. Now here we jump if no carry is our jump if no carry says either is carry or not. If this is false, so there is a carry, so we increment the C register, and if there is no carry, so then now our task is, now one thing should be remembered that our sum is stored in the HL pair. So we store the sum in what is our address. This is the starting address to store the sum 9006. So 9006 and 9007, in this two location the number is stored, the first summation is stored, that is BBA. Now this is the first method in the same program. This is the first method. Okay, this is the first method, that is we add this only this part by this coding. Okay, by this coding we add just on, we add this only, add this part only. So now again we add this part. So now depending on this carry we can next our 8 bit is summation will be dependent either carry is generated or not. So next again we starting from the starting, we initialize our third number. That means here this is 9002 and this is 9005. Yes, right, this is 9002, and transfer it to accumulator, and again LXIH 9005, and then addition operation is performed. But here one thing is we use, instead of add, we use ADC because the addition is performed with PP, QQ and the previous carry bit. Okay, so now ADCM. Now here we again jump if carry bit is generated. So now here L2 is mentioned. So if no carry, then store the result in what is the location 678. Okay, so why 678? Because is a second number and summation is stored 9006, 9007, and this is 9008, and carry store 9009. So our target is 9008. So store the result summation. That means what is the summation? The summation equal to CC. Now here one thing should be remembered, that before doing this, okay, we again initialize, before this we again initialize MBIC equal to 00. Here we initialize MBIC equal to 00, because if here 8-bit addition, during 8-bit addition, if there is a carry is generated, then we again increment C. So now move this summation value and then transfer the carry to the accumulator, and again it's stored to, yes, right, 9009 hex and halt. So this is the method by which 24-bit numbers, that is 3-byte number addition in 8085. So now we discuss this programming in a simulator ID. Okay, now for 24-bit addition, say the number considered here FF88, FE89, FE, FD considered, and this is EF. Now these are 24-bit number you consider here. Okay, now we open the 8085 simulator environment ID Ocean software, and this is assembler, and here we retain this code. So now first of all, MVI C, 00 hexadecimal, then LHLD 9000 hex location, then exchange operation performed, then again LHLD operation performed 9003 hexadecimal, then DAD operation is performed, DAD D, and is a DAD D, and then JNCL1, and then INRC, just place the code. Now again move A, M, okay, then again LXIH 9005 hexadecimal, sorry, is of hexadecimal, and ADC add with carry with M, and again here JNCL2 is, and then INRC is here. This is in capital letter SHLD, sorry, INRC. Now here L2 is another level. Okay, so now what is in the level 9008. Okay, now next then again HTA 9009 hexadecimal, and last one is halt. So this is the full line of code written here. So if there is any error, we debug this code properly. So now see that now this assemble and load, so there is no error. This error shows that there is any code error or any type mistakes or any level mistakes. The error in algorithm is checked by yourself because this program is written by you. So now see that in 900, what is the location of this is the location. So now we entered here the number. So first number enter is 89. Okay, enter 88, enter FF. Next number is FD, yes, right. Next number is FF. Next number is EF. Now we enter the whole numbers. This 3-byte, total 24-bit. Two numbers, each 24-bit are stored here. Okay, now using calculator, we also show the result. So using this hexadecimal calculator, we show the number first. The number is 89, 88, sorry, just a minute. The number is first FF 88, 89 plus with EF, then FF, then FD. So what is the summation result? The summation is 86, 88, EF and 1. Okay, this is our result. So look here, read is first, then start and the end. We look in the memory. So this is our last, this is 86, 88, EF and E1. Okay student, please matching between them. Is it right or wrong? So first is 86 the MSB bit. So look here, this is 3 byte, 1 2 3 3 byte, and this is second 1 2 3 3 byte, 2 numbers. And here from here we store our result 9006, 900 and uppermost 6, 86, then 88, then EF and 01. Okay, clear? So this is the 24 byte additions. Okay, so look that our result is same as this here in the memory editor result. So this is the first 3 byte, this is the second 3 byte, and this is 86, 88, EF and 01 is our result. This is LSB, this is a 2R, this is a middle bit, this is a MSB, and this is a carry bit. Okay, so 24 bit addition performed in a 8085 simulator IT. Now we perform our next program. The number is 0 or not, as we mentioned here. This program mentioned the number is 0 or not, so we see that. And here also you change your code. First of all, here again assemble and load, and 24 bit addition without carry, that means say 55, 55, 55 and 66, 66, 66, and after this result there is a no carry generated. So see here the result is okay or not. Here look at that. Yes, is it right or wrong? Yes, this is right, because the 66 plus 55 equal to, that means BB, that means 11 11. The 3 byte are BB, BB and BB, and here carry output equals to 1. Okay, the 3 results, 3 byte are contained BB, that means 66, 6 and 6 plus 5 equal to 11, and but in a hexadecimal 11 is represented by hexadecimal digit B. Okay, so now our next program is to return this program. Okay, now delete this part. Now again LXI H 9000 hexadecimal, move A comma M, and then aura A itself, then JNZ operation performed L1, then STA 9001, and here 1 halt is used, and here again the level is created, and here MVI equal to 01, because if the number is not equal to 0, and then STA 9001, then STA 9001. Okay, and then again halt. Okay, so now assemble and load. First there is a no syntax error. Now we see that here we enter one number, say 25. So this number is not equal to 0, so run the simulation, and after see that there is a 9001 stored 1, that means this number is not equal to 0. Now again assemble and load, and here stored equal to 00. So now we start the simulation. Okay, so after the simulation is see that here stored 00. So for so change this indication bit, we do another thing, that if the number is 00 then stored FF. So what we will do that for this method, now we MVI A equal to FF. Okay, if the number is 00 then FF will be shown at 9001. So now again assemble and load. Now this is 00, run the simulation, and after the simulation shows that here 900 content equal to FF, that is the accumulator content equal to 00. So this is the indication bit by which we can indicate the number is 0 or not in this programming.